Hello everyone. This is a problem from the chapter rotation and it involves an important concept involving rolling of a body on a horizontal surface. So let's read through the problem once. A solid billiard ball of radius r and mass m initially at rest is given a sharp impulse by a coup held horizontally at a distance r by 2 above the center. Just after the impulse, the velocity of center of mass of the ball is v, that is 10 meter per second. The coefficient of friction between the ball and the table is mu, that is equal to 1 by 2. The ball starts rolling without slipping t seconds after impulse is given. So rolling starts after some subsequent time. Hence we have to find the value of 1 by t. So let's see the free body diagram. This is the center of the ball, and at a distance r by 2 from the center along this line, a force is applied. Impulse is for a very small duration. It acts and then it is removed. So it will impart some momentum to the ball. As a result, it gains a velocity v. And let us say the impulse provided is j. Also, friction is there at the ground, but it won't act initially since the impulse acts for a very small duration of time. However, once the motion starts, the friction force will come into action. So initially when the impulse is given to the ball, we will not consider friction. So impulse j is provided, we have assumed it j, and suddenly it acquires a velocity v, the center of mass. So we can write that this impulse will be change in momentum, linear momentum of the ball. So j will be equal to m into b. This is the first equation that we get. Also there will be an angular impulse about the center of the rod, and this distance is given r by 2. So the angular impulse about the center will be j into r by 2, and this will be equal to I omega. Now for a solid ball, the moment of inertia is 2 by 5 mr square into omega, and j we have already calculated. The value of j is equal to m into b. So let us substitute that value here. So m into b into r by 2 will be equal to 2 by 5 mr square omega. Mass will get cancelled, one r will get cancelled, and so from here we can directly get the value of omega r, which will be 5 v by 4. So let us call this second equation. Now if I compare this value of omega r with v, definitely omega r is greater than v, and for pure rolling we know omega r should be equal to b. So there will be slipping, and what will be the direction of slipping we can determine from this value that we have derived. Since omega r is greater than v, this point which is in contact with the surface, this will have a tendency to slip backwards since omega r is greater. So the friction force will act in the forward direction, and because actual slipping will take place, so this friction must be equal to mu times n. Also, normal reaction in this case for a horizontal surface, the normal reaction will be equal to the weight of the body. So the friction force will be mu times mg. So this impulse is provided for a very short duration, and then it is removed, and subsequently friction comes into action. And given the direction of this friction, we can say that this velocity v of the center of mass will increase with time, and this friction will provide a torque about the center. And if omega initially was in this direction, we have already calculated omega r equal to 5 b by 4. So the torque of the friction will oppose omega, Subsequently, V will increase and omega will decrease, and after some time, V equal to R omega condition will be satisfied. We have to find that value of t, what time. So let us calculate the angular acceleration provided, or in this case it will be retardation. Friction will retard omega. So the torque due to friction about the center will be F into R. This perpendicular distance will be R from the center equal to the radius, and this we can write as I into alpha, I about the center. So F is mu mg into R, and about the center the moment of inertia of the solid ball will be 2 by 5 mr square, and into alpha. Mass will get cancelled, one R will get cancelled, and we can get the value of alpha as 5 times mu g divided by 2r. So let us call this equation number 3. All these equations we will subsequently use in other equations. So after some time t, the velocity v final we can write as v plus acceleration in the direction of v will be provided by friction, and that will be mu into g into time t. Call this equation number 4. And omega final will be omega, and it will decelerate. So minus alpha into t, and alpha we have already calculated, 5 mu g by 2r and into time t. Call this equation number 5. Once pure rolling starts, the condition v equal to r omega will be satisfied. So vf equal to r omega f we will write, and we will substitute the values from 4 and 5 in this equation. So v final we can write as v plus mu g into t, and r into omega f will be r omega minus 5 mu g by 2 into t. R omega we have calculated from equation number 2. R omega is 5v by 4. So we will substitute that value, 5v by 4, and minus 5 mu g t by 2. On the left hand side we have v plus mu g into t. So taking the terms of t on one side, we will get this will become plus on the left hand side. So mu gt plus 5 by 2 mu gt will be 7 by 2 mu gt. And on the right hand side, 5b by 4 minus b will give us b by 4. And from here we can get the value of t. 2 will get cancelled on both sides. So t will be equal to v divided by 14 times mu g. And we have to calculate the value of 1 by t. So 1 by t, hence we can write 1 by t as 14 mu g by v. And if we substitute the given values in the problem, we will get 14, mu is 1 by 2, g we can take as 10, and v it is already given, it is 10. So this 10 and this 10 will get cancelled, and 14 by 2 will give us 7. 1 by t, so it will be second inverse. So the value of 1 by t is 7. So that is the answer to this problem. So basically we have to consider the impulse provided by the coup. This impulse will provide some velocity v to the center of mass. Also this ball will be given an angular velocity also, and both we will calculate and check whether v is equal to r omega, or v is less than r omega, or v is greater than r omega. In this case we got omega r greater than v, so slipping will be backwards, and so from there we can calculate the direction of friction, and subsequently we can write the equations of motion, solve it and get the value of t, or 1 by t in this case. So that is it. Thank you very much.